Hello everyone, I am Kiran from Sri Venkateshwara College of Engineering, Bengaluru. Today I am going to discuss one of the topic in data structures and application, that is stacks in data structure. Let's see the introduction to the stack. Stack, it is a linear data structure that follows the last in first out principle. It consists of elements organized in a specific order. We can push or pop only at the top end. Stack operations. Push and pop are the stack operation. Push adds an element to the top of the stack. Pop remove and return the top element from the stack. Stack implementation. It can be done using array or linked list. Array implementation is simpler and more efficient for small sized stack. Linked list implementation allows for dynamic resizing and is suitable for larger stacks. Now let's see the array implementation of a stack. In an array implementation, a fixed size array is used to store stack elements. The top of the stack is represented by a variable that keeps track of the last increased element. Push operation increments the top variable and inserts the element at the corresponding index. Now let's see the push and pop functions. First, we have to check whether the stack is full or not for the push operation. By that, we can add an element. If it is full, we can't able to add. By the stack plus plus top is equals to element, we can add. Popping an element can be done if and stack is any element. If it is not, if the stack does not contain any element, by we can know that by top is equals to -1, then the stack underflow goes, that is stack empty. Or else if there is not if there is an element, we can delete that element by stack top minus minus. Linked list implementation of a stack. Linked list contains two nodes, that is data and next link node. In a linked list implementation, each element in the stack is a node that contains the value and a reference to the next node. The top of the stack is represented by head node. Push operation create a new node, updates the head reference and link it to the previous head. Advantages of stack. Stacks are efficient for managing function calls and recursive algorithms. They can be used for reversing the order of elements. Stacks are useful in solving problems that require backtracking or undo operations. Let's see the applications of stack. Function calls and recursion. When a function is called, the current state of the program is pushed into the stack. When the function returns, the state of the popped from the stack to resume the previous function's execution. Expression evaluation. Stack data structure is used to evaluate expressions in infix, postfix, and prefix notation. Operations and operands are pushed into the stack and operations are performed based on the stack top elements. Browser history. Web browser uses stack to keep track of web page you visit. Each time you visit a new page, the URL is pushed into the stack, and when you hit the back button, the previous URL will be popped out from the stack. Here are some of the real time example of the stacks where the stack of coin, stack of plate, and stack of tennis ball, stack of books. We can only insert and delete those things from only a top end. Another application of stack is tower of Hanoi, which are used by the recursive function, where it will move from one pole to another pole in a some given order manner. Limitations of stack. Stack have a fixed size in array implementation leading to potential overflow. Linked list implementation requires extra memory for storing node reference. Stacks are not suitable for accessing elements in random order. Stack versus queue. Stack follows last in first out, while queue follows first in first out. Stacks are efficient for accessing the top element, while queue are efficient for accessing both at the ends. Both data structures have different applications based on their properties. Visualization of a stack. Stack can be visualized as a vertical structure with elements stacked on top of each other. The topmost element is the one accessible for operands. New elements are always added on the top and old elements are removed from the top. Example of this visualization: demonstration of a stack operation sequence using visuals, visual representation of a push, pop, and peek operations, illustration of how stack elements change during the sequence. Now let's see the real world example, that is browsing history, call stack in program, undo and redo operation. Browsing history. Each page visit is added to the stack and the back button pops the last visited page. Call stack in program. Keep track of function call and their respective local variables. Undo redo operations in the photo editing software. These are the real world examples. Now let's see the conclusion. Stack are the fundamental data structure with a wide range of applications. Understanding stack operation and implementation are crucial for efficient algorithm design. Stack provide an intuitive way to manage elements based on the last in first out principle. Thank you. Thank you for watching this video.